sitting on the floor.
I know.
Okay, you're streaming and live and recording all that stuff, so don't say anything offensive.
Oh, this is the wrong person.
I know.
Did I say anything offensive because we just ordered food? I just heard. Sorry about that. Sorry.
Way to go, Sean.
15 minutes ago, and Jessica's like, I don't know, but you know, details. Yeah, not my strong suit. I did get feedback from one of the clients that came to the last one you gave. He said it was like awesome. It was magic.
Who was it?
Jeff from Chipotle.
Oh, it was good to have him there.
But it's been making like we need AWS.
Well, they can, it's production now in Azure too, in US East. But what, they're probably on, you're probably building everything on US West too instead of US East too. Where did
Did you get my email?
I did,
Okay.
but I haven't read it.
Okay.
I have fallen so far behind.
No problem. I did talk to Pat though yesterday too after we
Oh, cool.
Yeah. So that was good. And I got an email out to Alice.
Oh, okay.
Yep.
Nice. Jason, is this part of you or was this?
No, that is not me. What's up, Eric?
I come for the first 30, so I thought I'd do that.
Cool. Hey, everyone on the thing, we're just giving folks a few minutes to come into the room. In one place. All right, I'm gonna go ahead and get started. So I can't see who all's on the meeting, but we'll go ahead and start hopping through this. So just for some reference, what we're gonna walk through today is a demo that we gave to about 30 prospective clients here a couple weeks ago. You know, happy Mark to send you a link if you wanna follow along and kind of do it yourself in the process. And then, yeah, if there's anyone else who wants something, please just ping Mark, and Mark, if you're all right, or Sean, I'll ask you guys just to field any questions or things from folks that might be on the line. All right, so the content, just a couple things to walk through. So how many people here actually know what Snowflake is? Yes. All right, 1/3 of the room. We're off to a great start. So from an IM&A perspective, we obviously have probably 150 different partners from a Salon perspective that we engage with on a irregular or a non-existent basis. Snowflake happens to be one of those though, where if we think about our big bets over the next probably 18 months is a technology platform that we're really excited about. A few things here just to know about Snowflake. So first off, it rides on both AWS and Azure. So depending on our clients, one of the good things here is that it allows us to essentially train our team in one technology across many clouds. The other piece is that as we think about data proliferation and having different types of data, different ways that we pull data in, different formats, different use cases, the thing with Snowflake that's really nice is that it allows us to do all this in one place. So not a lot of our clients in Denver have things like Hadoop and other sources. But essentially what this platform allows us to do is to pull in everything, treat it like SQL, and then have our clients unlock value from their data incrementally versus big bang waterfall type approaches. The other thing, and probably more relevant for folks in this room who are speaking to clients about maybe why, what's different about Snowflake than other things. First thing to call out is that in Snowflake, you're essentially paying for use. So our clients used to have to spend millions of dollars in capital. You'd plan for hopefully being right 3 years down the road. You'd inevitably miss that estimate, either way too high, way too low. Finance would never trust you again. The nice thing here is that folks you essentially pay per use. So the more you use the tool, the more you pay for it. A really relevant use case for one of my clients currently, and where this would be more beneficial, is we're actually standing up a new application and we don't know what the usage pattern is going to be. So in this case, we can set something so we're not paying a lot because we don't know how many people are going to use it. But as more people use it, we can start to ramp up essentially the capability and the capacity of the machine itself. The other thing here, and I think this is a really interesting thing, I don't think a lot of our clients have fully thought through this, and it's a great opportunity for us to be a part of the conversation, is data sharing. So data sharing at its simplest level, in this instance, is either internal sharing between departments. So how are we not cloning data? How are we not replicating data 25 times on a share drive, but using a single source of the truth and everyone using that for different purposes? The other one is how do we share data externally? So if we think about a lot of our financial services partners in particular, how are they sharing data with their external companies? Or for things like GDPR, how are we getting, apologies for that. Let me figure out how to turn that off. There, I think that did it. How are we getting different pieces in here? And then for some of our different companies, what does this actually look like? So a good example of this is how do we share market data? So we have companies that maybe do like market research for us. We maybe have companies that do third-party targeting. The great thing about data sharing in Snowflake is that we still own all of the data that we're sharing out, and we can shut off access essentially within 5 or 10 seconds notice. So for a lot of our companies where they're worried about things like GDPR, HIPAA, PCI, we can actively maintain and manage that with our different client bases.
Jason, real quick, who owns Snowflake?
So Snowflake, that's a great question. It's a privately funded company. They are the largest private equity company in the data space right now. They're US based, they're based out of Seattle. To put it in perspective, the next best funded company in terms of venture capital has about 75 million in funding, and Snowflake just got 250 million in a Series D funding.
Wow.
So in terms of like good technologies that will be around, like this is one that I would anticipate they either go public or they get bought by Amazon or Azure.
Sorry, since we asked a question.
Yeah, please make this interactive.
Are you okay with that?
Yep.
What about stupid questions?
Even better.
Curiosity was a good start.
What is it?
So at the simplest level,
Highest level, yeah.
at the simplest level, Snowflake is a database. What's different about Snowflake is that if we think about the cloud and how cloud separates storage and compute, Snowflake also separates storage and compute at a database level. So in Amazon as an example, when I spin up a database, I have to spin up capacity for the database, so storage, and I also have to spin up compute at the same time. Snowflake allows you to store as much data as you want in it for the cost of about $23 per terabyte per month. Then however you use it, you essentially spin up a warehouse in Snowflake terminology, but that's just the compute to go access all that data. So for our clients, one of the toughest things for them to wrap their head around is that it's not on all the time. If it's on all the time, you're gonna spend way too much money. But most of the time, like our clients don't need things to be on at 10 p.m. at night. If I'm doing data science work, like my data scientist is working on the data 2 to 3 hours a day, and then I don't have to pay for it the rest of the time. What that means, though, is that instead of having a small database that I have to run 24/7, I can use a large data warehouse for 2 hours, and I actually get better performance. So my customers are happier, and I'm still paying less in the process. Yep.
So if you're running it on a schedule basis, I assume there's like some startup time in the morning, like if I need to use it, like by 10 a.m., do I have to start it up at 9:30?
No, so it's near instantaneous start. So the caveat, if we go really technical for a second, is that when you have a warehouse, it can load things essentially into hot memory. And so if you want to do that, then you would need to spin it up and execute those queries before someone would need to use it. It's no different than a Lambda function, like a cold start. Other questions?
One other question. So this secure data share sounds really cool. Is it easy to test whether you've got the permissions right before you share that out?
Yep. Yeah. So from a usability perspective, I think this is actually one of the biggest benefits of the tool. So if I come in and look at this here, I can essentially look at everything about a database with 1 or 2 commands. So from a sharing perspective, if I log in, I'm just going to hop over to the account admin view. When I set up different rights in here, it's essentially 10 seconds for me to come in and then say, oh, I don't want this user to have access to this data. I'm going to cut them off. So when we think about our different, all of our different use cases and different clients, what we run into a lot of the time is that I have to replicate my policies across 5 or 10 different things. And then here I'm controlling it once. And then it makes it really easy for me to audit that and then to manage that going forward.
So that's good for triggering the ability for you to see where theoretically you have given access to something.
Yep.
Is it easy to test?
Yep. So if I was to come over here, I can essentially put myself in any of the roles that I have access to. So for me, I have account admin access, which means I can role play as any one of these things. But you could say, hey, like Eric Olson should have select rights to this role, and he should have admin rights to this role. And then you can come through and actually just trigger those on the fly, either via this or actually by worksheet or by query, to say, hey, Eric wants to run as something else here.
So I hate this, especially PCI HIPAA compliant.
Yep, so there are 3 versions of Snowflake. On the pricing sheet or on their website, you can see the 3. Standard and Enterprise, there's just some technical feature difference, but there is a version called Enterprise for sensitive data, and that version is HIPAA and PCI, and I think SOC 2 compliant.
More expensive probably.
It is, it's $1 more per credit. So Snowflake, everything is measured in credits from a warehouse perspective. Roughly think of a credit on Enterprise, the rack rate is $4 an hour. So if I use an extra large, which is 16 credits, I'm paying $64 an hour at the list price. Internally, when we talk to clients about it, like you could assume anywhere from probably a 15 to 35% discount depending on the size of the volume.
Directly compete with Google or Amazon?
It does. So it competes with Redshift, BigQuery, and Azure Data Warehouse. One of the interesting tidbits, and I don't believe this has changed, but AWS would actually recommend customers move to Snowflake when they ran into issues on Redshift. So from an AWS perspective, they're incentivized on essentially compute. So whether it's Redshift or Snowflake, because Snowflake has their giant farm of essentially of servers that they have, for them it was negligible at the time. And then I've heard rumors that they'll be on Google Cloud as well, probably in the next 12 months. Mark?
So if you're a customer existing and you're using Redshift, for instance, would I just be able to point to my S3 plugin and just basically have Snowflake ingest all my
That's such a good segue right into the demo. Did Sean ask you to ask that question?
No, we actually have a mental.
Yes, so in terms of how we get data in, so a few things. At the end of the day, Snowflake manages its own data and its own partition management of the data from a system perspective, but you can connect directly to S3 or to Azure Blob Storage. So depending on the platform you're on, there are different ways to store it. But it works essentially a very similar way where we can set up an S3 account as a stage, and we can pull that data in. Cool. All right, so the other slides here. Who wants to learn about slalom? What is it that we do? The one slide I will touch on from the stack, when we think about modern data delivery, there are really 5 tenets that we think about. So I think where this is relevant for this group is just, when you work with us and you work with us on something like an MSBI thing, here's how it might be a little bit different. First thing, starting with the plan, we obviously always should do this at the outset, but I think the bigger changes are, in the cloud, we're really designing for recovery. What?
We have a meeting with the client in about 2 hours, and I think we're gonna pull the slide out.
Yeah, it's a great slide.
This is gonna baseline like why we're having this conversation with the client. Real time. Can you just do it, or we'll get lunch?
I wish I could take credit for this one. So the 5 things at the top, first one, design for recovery. So it's not about always being right. It's about how do we essentially design for things like reloads and other things just as a part of daily life activities. Client in Charlotte that I'm supporting reloads data to put in perspective about twice a month to their Teradata implementation, and it essentially brings down every other user in the process. So in this case, what we're trying to do is say, hey, how do we just plan for that to happen so when something does happen, we can recover very quickly from that. Second piece, designing for change. So using something like Snowflake, because we have everything in one place, it makes it really easy for us to make a change really quickly and not have to change the 15 things and the launch codes to make that happen. Thinking about security, Eric, I think to your point, it's as much policy and role, but it's also kind of who has the need to know, and then what is the governance process around supporting that, and technology never solves that problem. And then last one, and what's really gaining a lot of momentum is how do we think about Agile and DevOps for data, which is now the buzzword for it is data ops. But that's really how are we doing things like continuous integration? So always testing, always putting everything together, and then continuous delivery. So always pushing things to production and it being available for our customers. But how do we do that with data? Because working in a data environment is very different than working with an app dev thing where maybe if I have a bug, it's not critical, and I can wait 4 weeks to make a change to it. Any questions? Yeah.
So one of the things that I think we run into at clients is they ask about the quality of the data, and I'm wondering if we can kind of skirt having to address that, whether it's in a golden record or confidence levels assigned to the data. But we continually get asked, are we creating something that's perpetuating bad data? And so are we avoiding the confidence level or the accuracy or the data quality around the data criteria? Okay.
Yes. Well. Yes and no.
Right.
Yes, this is not, a tool like Snowflake is not a panacea to saying that your data is grade A or grade F.
Right.
Where a tool like this helps is that we don't have to replicate data nearly as often. So, where this really comes into play is if I think about an IT organization owning a golden data set.
Right.
So this is my production data, IT has put its stamp on it, it's great, even though in reality it's probably not. How do I share that with a department like marketing? In Snowflake, I can create things like zero-copy clones. So zero-copy clones mean that I just replicate all the metadata about the table to that group, but they actually connect to the singular source of data that I'm providing to them. So things like that actually typically increase your data quality, because what happens is Jason and Eric both download a file. Eric uses like SUMIF, Jason uses COUNTIF. Okay, now I'm different, now we have a problem. So things like that, this is designed to try to alleviate some of those things, but it's not a, it's not like an automated governance tool from that perspective.
What you said makes a lot of sense because there's times when you have to sort of back in and go back and figure out how each one was created and why they're different, and then there's questions
Yep.
as to which one is right. So that helps that you show the detail behind it. Yeah. Okay.
Yeah, in this case, so like for one of our, we're scoping this for a client currently, and that's actually one of the use cases is, sales comes in, they want to add in all their own impression stuff, but then they mess up the original data set. Well, I can go in this and I can say, great, like here's when we provide you this copy, here's what this copy was, and here's what you did to mess it up.
Yeah, exactly.
So it's very, like the lineage gets a lot easier to track in this system.
That's huge.
All right. Slalom's core values, anyone? Smile, is that the best one? All right, so let's hop in. So you can see here, there are a lot of different databases that are existing here. We're going to go ahead and create, for the sake of this demo, just create a few of our own pieces. So I'm just logged in as myself. The first thing I'm going to do is I'm going to create a database for myself to essentially do this work in. So in this demo, what we'll walk through is essentially taking data from S3. It's just in a public bucket. Bad security policy, I know. We'll load it in, and then we'll do some queries against that, and we'll see some of the different capabilities that Snowflake has. So the first thing I'm going to do is I'm just going to create this database here. Oh, let me run it up here.
Need help, it's probably a semicolon file. I run this all the time.
That's funny. All right, so first thing to note, so I just did a simple statement for creating a database. Snowflake is fully ANSI compliant, so things like create or replace, create if not, I'm using if not exists, or things that come out of the box. Things like this, which seem very simple, are actually very powerful if we think about users creating different tables, creating different databases. Here what I can say is, I'm using if not exists to say if it's already there, give me an error. So don't overwrite stuff that I shouldn't be overwriting. If I did want to do that, I could actually use create or replace, so I could always be overwriting whatever is in place for that. Different use cases are really relevant for different ones. So now that I have that, the other thing to call out here, and this is just on the view from the browser, I have all my history that I'm running. So in this case, I can always go back and I can replay something from a previous step. Where this gets really beneficial is, as we think about usage in Snowflake, I pay for compute based on the initial queries that I run, but Snowflake also stores all of my history for up to 14 days. So if I run a query and it knows that the metadata hasn't changed below that query, I can actually pull back all of those results without ever spinning up a warehouse to do the compute on it. Think about things like, where this comes in really beneficial, things like Tableau or app dev use cases where it's the same queries that the users are running all the time. Now I'm not paying to essentially have upkeep and try to rerun that all the time.
Build your own cache because they build it for you.
They build the cache.
So do we just pay for a second worth of time and then all that history that's right there?
Yeah, so warehouses are charged by the minute. And so I've set auto suspend on all mine to be it will auto suspend after 5 minutes. There are use cases where we don't want to set auto suspend, but those are typically things where it's like a production application and we want to keep the data hot. So now what I'm going to do, if we look, I have some of these things that are set up here, but I'm just going to run this statement to use this database. And now what I'm going to do is I'm going to create a stage. So a stage in this case is connecting to this S3 bucket that has my data. The other plug that I'll make is if you're on Snowflake, they actually have a really good online repository for commands. Probably one of the better ones I've worked with in terms of cloud partners. Yeah.
So if I've set up like Tableau to have dashboards for things, are you saying I can pre-cache stuff so that people get data
Yeah. So two things to separate in that. So the database is actually, in this case, and this is where Snowflake's nomenclature is a little aggravating at times. The database is just the data that's stored on their own version of S3 and partitioned. The warehouse is what they would have to spin up in order to access all that. So yeah, if they're running the same queries all the time, you can theoretically run it once and shut it down, and then they can just access the query results without ever spinning up a warehouse to access it again. Shameless plug here, if we think about all the things that we work in cloud, especially the newer file types, Avro, Orc, and Parquet, these are all supported. The irony here is that Snowflake, from an ingest perspective, they've done a lot of benchmarking, and gzip CSVs are actually the fastest by probably 50% in terms of loading in.
So does it still have to deal with file typing or data typing though when it reads in and like figuring out, like, do you have like a bar car 50 or?
You're jumping ahead. Is it schema on read or schema on write?
So it depends on how you load your data in. So another great segue to talking about file types and file formats, I can actually customize as many as I want to have in the tool for how to load it. I can load in things like JSON as just what they call a variant data type, and then I can query it with JSON notation. So that part's really nice if you don't know, you don't know how valuable the data is yet, and you don't want to spend a lot of time developing all this stuff out. You can just go in and then say, hey, I want to load it in as a JSON, and I want to do some data exploration. We also developed a set of code for Charter, which is essentially an automated DDL generator. So it'll go in and it will actually, you can specify different sources and different file types. And it will go profile and then auto-update Snowflake schemas based on that. All right, so I've created my connection to S3. Next thing I'm going to do is I'm just going to come in and I'm going to list what's in there. And I hope it works. There we go. So you can see here I have all this different data that's available in the bucket. I have essentially the MD5, so the hashes for that signature. I also have the modified dates for this. So where this comes in really, really useful is when I start to load data, Snowflake will actually take the MD5 and say, was that file already loaded? And it will automatically manage whether something needs to be pulled in based on the queries that we run. All right, so next thing I'm going to do is I'm going to create a table. So I've created that. I'm going to come in, I'm going to create my file format. So this is just a CSV, and I'm skipping headers. And now I'm going to create my warehouse, because as soon as I start to load data in, I need to have a warehouse to essentially perform that transaction. Some transactions like this one where I'm just creating DDL and doing those sorts of updates don't actually require a warehouse to run.
Can you put all your DDLs into like some kind of a source code repository and have it pull that stuff in so you can have true like infrastructure as code?
You can. So one of the reasons that actually a lot of our clients are really high on this tool is because of the native driver support. So if you think of like having source control, I can come and I can create a Python script with a native Python connector, and then it can pull in all of that automatically. So I'm using the worksheet just because it's a little more visually appealing, and I can do things like look at my history and do kind of that data science-y profiling. But Mark, for your use cases, and you're coming in like building this stuff out, our clients actually love that there's like a native Node.js driver as an example for this. All right, so now that I have an extra small, I'm going to load this data in. Yeah, all good. See you later. So what you can see here, now that I'm actually loading data in, it will also tell me what it's doing. So how much time is it spending on each stage of the process? One of the things to note, and this is what we learned on an engagement tuning this, is that we do have cloud latency. So unlike things that are on-premise where everything's sub-second, we do have to plan for it when we're doing something like this with Snowflake. But it just is a different design pattern to consider.
Do you have region affinity? So can I want to be US West 2 or US East 1?
So they are in 2 zones of the US. So they're in US West 2 and US East 1. Our slalom instance is in US West 2. In Azure, they are in US East 2 currently. And then I also believe they are in EU Frankfurt for AWS.
So how big are the data sets you're loading right now? How big are they?
They're about a gig.
So gig total between these 3 you're loading?
Yeah, these are pretty small. I mean, from a demo purpose, like, I try to keep them pretty tiny. In terms of loading data in, if you're using an Excel, you can load upwards of a couple terabytes an hour. In this case, though, we don't really, we don't need that.
Oh, just, it's a little setting expectation, right? Because there is the latency, you've got to read these things in, et cetera, et cetera, et cetera.
Yeah, so there's a technology that they've developed on AWS called Snowpipe. And Snowpipe essentially it enables you to post files direct to S3, and then Snowflake will, in an automated fashion, load that data. So if I'm just like continuously ingesting stream data, I don't want to have to come through and run micro batches of this stuff. It's really, it's an automated way to load it. So they'll take care of the loading process. You just have to specify the keys and then tell it what notifications to do stuff with. In this case, you can see I've loaded all these records, so I can see the rows, the number of rows, the number of rows loaded. I can see my error limits. I can see any of the errors that I also got in the process. So if I wanted to set and say just ignore rows that are bad, most relevant use cases like marketing impressions, I'm getting 1 million of clicks. If I lose 0.5 to 1% of those, I probably don't really care. Financial data, like if I lose 1 record, then I do care. It just enables us kind of that configuration capability. You can see here, though, for each of the queries, Sean, going back to your question, so in this case, I scanned 1.3 gigs. In this one, let me click the query. So in this one, I scanned even less. And then one of the things I really like in this case is really simple, but it actually has a visual query analyzer. So if anyone here has tried to read like a database explain pattern, it's usually one of the most painful things that you've probably done. In this case, it'll actually just break it out, and then we can see what are the most expensive operations by step. So here I can see I've loaded 133 million. The external scan actually wasn't very expensive. The insert was more expensive. Pop back. All right, so if I think of this, so I look at the total time to take this. So this was 46 seconds, 23 seconds. So let's call this a minute, roughly a minute 10. So this could be like a minute 25 to run. Let's say I don't, I'm like, yeah, I don't want that. I want my data to be loaded a lot faster. So I'm going to go ahead and I'm going to kill that table. Then I'm going to come in, I'm going to recreate it. I'm going to alter my warehouse to be a large. And I'm going to come in, I'm going to load this data again. So now you can see I've essentially kicked off the same job. So I changed my warehouse, I reset all the cache in it, and now I'm going to load this new data. So we can see the first one only took 8.7 seconds versus 12. So we scaled up essentially, if you think of an extra small as 1 node, a large is 8. So we scaled 8x. Not necessarily the change in that one that we were hoping for, but the larger data sets then start to go pretty fast in this point.
But you're paying 8 times the credits.
Exactly. Before Snowflake, so when Snowflake was on per hour pricing, they always recommended to go smaller. Now that they're on essentially per minute pricing, the recommendation is start with a large, and then if you don't need it, scale back down. And that's because actually typically the quicker the query is, the less you're going to end up paying. It's a very counterintuitive thing. But if you think about it from a technical perspective, if you think of a large as 8 nodes, when you have 8 nodes connecting to their storage and pulling in data, you can pull in essentially data 8x the speed versus a single node or an extra small. So you can see in this case, my query times went down a decent amount from this, and now I'm loading data in about a minute. And where some of these things, this becomes really beneficial is when I start thinking about things like concurrency, how complex is my query, and then starting to design a solution that really kind of optimizes cost, performance, and concurrency. All right, I don't need that one, so I'm just going to go ahead and reset to an extra small.
So you could scale it up to large to zoom in and scale down small for, after you keep the data in.
Yeah, so typically what we recommend is set up a warehouse to do all of your ETL. And that way users aren't impacted by that one just running over time, and then have separate warehouses for the different use cases that you might need. Nike, as an example, was moving very quickly to Snowflake because one of the great things was finance liked to write really crappy queries on Hadoop. And they could say, great, finance, you want to write bad queries. Now instead of bringing down the cluster, you're just paying 10 grand a month. So the cost allocation in this is really straightforward.
And I assume you can copy data back and forth between warehouses pretty easy. And that's
So a warehouse, you never actually load, a warehouse doesn't have data.
oh, it's crunching data. I apologize.
Yeah, so you can have 10 warehouses hitting the same data, and they're not going to be impacted by each other. So when we think about how many of our clients, Jason writes a query, Ben writes a query, Mark writes a query. Jason's query was the worst one that was written of the bunch. He just locked both of them from being able to view data. Yeah, in Snowflake world, I can have my own warehouse and it gets billed back to my group. Ben can have his own warehouse. Mark can have his own warehouse. Scott could have his own warehouse.
Now, this is the client who let's talk to. This is the problem, but they're already in big. Yeah, I was gonna say that was the only reason why I think we need to keep these stuff. Okay.
So if everybody has their own warehouse, how do they prevent contention? Data contention issues. If I'm querying the data or writing against someone else has a warehouse and they're writing the same pile of data, you need to keep separate copies of the data.
Yeah, so you can actually go back. So Snowflake, if we go down here a little bit later in the demo, we can do things like undrop. We can actually time travel on the table. So think of this as true temporal tables. And depending on which version you're on, you can time travel up to 30 days. So the only thing to note with time travel is if you store 30 days of changes, you might be storing anywhere from 2x to 5x the amount of data, but at 23 terabytes a month, that's usually pretty small in the scheme of things. I can go though and I can actually take different things and I could say, okay, based on the time, make a change to the table. Oh, I didn't want that, and I can just roll it back essentially in 2 statements. All right, so in this case, what I can do here is if I'm just gonna drop it. So now it's dropped. If I try to query it, doesn't exist. Bad JSON. Undrop it. Yeah, I went from having a near heart attack because I accidentally dropped something in production to now I'm relieved and I'm questioning whether I will ever do that again. So time travel, yes. So what I could do in this case, let's say I'm going to get the current timestamp. I'm going to plug it in here. Let's say I want to make this update. So this data set has dispatching bases, and there's 30 or 40 of them in there. What I'm going to do is I'm going to run an update, and I'm going to change all of them.
I forgot my workflow, so that never happens.
Yep. 1 second, team. Yeah, so I'm on a small warehouse. I can see here, what's taking, I can see essentially how far is it progressing. I can see, what's taking the most time in it.
Is it ACID compliant or is it eventual consistency? Is it ACID compliant?
It is ACID compliant. All right, so it's done. I updated it. I updated 400 million records. I'm gonna run my dispatch. Oh, crap. So what I can actually do is I can go back and I could say, okay, let's look at this data before I made that change. Oh, look, I can actually come back to that. So I've gone back in roughly a minute and a half. And now I can say that what I can do is I can say, okay, now that I have that, or I could actually go by query plan. So like, let's say DBA, user doesn't have access to do this. I ping Mark. Mark, I'm really sorry. I did this. Mark can actually go back, and if he has the view on the history, he can say, oh, that's okay, Jason. I support everything that you do. I'm a really nice DBA. I'm going to go back, and I can see, oh, here's the statement that you ran. I'm going to go find this query ID, and I'm going to roll back to just before that query was executed. So if we pop back here, what we can see is I can actually come through. So I'm going to create what we call a clone of this table at this particular timestamp.
You could have done an insert, like an update join thing, I guess, too.
Yeah, I mean, honestly, this is easier. So what I'm going to do, I do lose some. When I clone, there are some things that I get back. I don't necessarily get back all of the time travel. But when I clone it, what I can do is then I can just drop it and I can rename. So if we think of in database terminology like flip tables, this is something that we can do a lot in this instance.
I'm just thinking so I'm taking a sideways way for this.
So you can see here, it's basically saying that the time travel isn't necessarily available for this table, but that's because I just need to go and then say, okay, what do I need to drop on these pieces?
Wait, I don't think you updated the date.
That's probably true too. Oh yeah.
I'm just thinking all the PSA stuff and everything like that that's in the current model where we're keeping a bunch of individual records, so we can do a query to say what did the data look like at a certain time. Now you don't need that because you just keep the data live and it tells you.
Yeah, so it depends. So like when we think about time travel, like a couple of things that I think of. One is time travel for the purposes of what we do as developers and making sure that we don't screw something up. Something like this is really great in that instance because I can always replay what I did and I can go back and say, okay, how do I make something different from that? Where it gets interesting is when I think about like record versions. So time travel in this case, you can do that for a period of time, but in some cases it might still be more beneficial for you to save off each version of a record.
You can't go indefinitely back in time like that.
Exactly.
Period of time. Okay.
Even like when we think about like temporal tables in like a SQL Server sense, the issues that we run into that typically are around storage on that stuff. So we might still do things like slowly changing dimensions because we need to like very explicitly say what we need to track. All right, so now that I've created this table, what I'm going to do is I'm going to drop the FHV data table. I'm going to run this. Brought it back. Now I'm going to go and I'm going to look at this again. now I have my original data set back. So literally in the course, in this case, it's a small table, but in the course of a couple of minutes, I've reverted my ill-advised decision. So the other piece here we can see on the history plan, I actually have all my statements, so I could go back and say, well, what was it at this point? Okay, here are my rows, here's my, here are the different pieces about it. I could say, well, what happened on this piece? So it's just a very easy and visual way for us to say what's going on with everything that we're doing.
If your data sets are like more enterprise type size, like petabyte scale, do these kind of reversions take like significantly longer?
They can. So this is where the question, if you're working on petabytes, you probably don't want to use an extra small warehouse to query it. But there are things that we can do. So this is where one of the things that Snowflake does actually pretty well is it will automatically manage its own partitions behind the scenes. So it will say, based on, once you start getting it probably like tens of queries, it will say, well, the data should really be clustered this way. In the Snowflake terminology, a cluster key is very similar to a sort key in Redshift. So think of it just like how am I grouping logical sets of data together in each of the partitions for querying. I could go through and I could actually manually set my cluster keys as well. So in the case of what we did for Charter and Charlotte, we had to set them at the outset because we couldn't wait for the system to learn and catch up to what we needed to do. From a petabytes thing, so if I had all the partitions, this data set's really small. So it's probably gonna tell me that there's like one partition that's available in it, or there's no partitions available. Because I don't have clustering on this. But you can go through and we can actually look at, what's my distribution, are there different things I can be doing to tune it? And then what's really nice is that when you think about refactoring, like I can refactor with someone else still doing work on the current thing. So it's not like Redshift vacuuming and all that, where you essentially have to do it at night and like hope that no one logs in because the system's fully loaded. Only go up. Well, you can scale out now to an extent, but it's not instantaneous. So one of the things in Snowflake that's really nice, wrong tab, is I can actually set it to scale out on demand. So I could say based on, I'm gonna find my warehouse here. This is showing my load, so I'm not really using much of it at any point. But if I configure it, you can see here, so here's what I've set on this. I'm using this size. I can actually set up this to scale out up to 10 nodes or 10 clusters. So I could have a large, and then depending on my usage, like I could say when it hits this point, spin up another one to do this sort of work. I can set my scaling policy. So this essentially means like, how is it gonna scale out? So is it waiting for queries to be in the queue? Is it being very aggressive? So it's basically as soon as another query comes in that hits that, it kicks it over to another cluster and then starts the work. It really depends on the pattern. Like if this is a data science thing, like I'm not gonna set it to be really aggressive, right? Aggressive stuff is for customer workloads where I probably have an SLA on my application. But I don't want things to be waiting. So it's that customer experience piece. And the other piece is my auto suspend. So in this case, I've set it to 5 seconds. So I'm basically never paying for something, but I could say, hey, actually never shut it down.
I'm gonna ask the question here, Jeff, but building an app and it needs to scale kind of, right now it may not need to scale a whole lot, but we don't really know what use it would be. Could I use this as my relational database if I wanted to?
If you wanted to.
So I can do my inserts and everything directly into it, and it would handle all the storage and all that stuff. And then I can set up separate warehouses. So like a lot of times people have their relational model they use for transactional. They do ETLs or whatever to get to a different model that they use for their data warehouse. So now they have 2 database systems. So we can set up 2 warehouses on one database. Have one of the warehouses be where we do all our inserts. I guess we don't even know if we can.
You don't even need to do like that. That's overcomplicating it. Yeah. Like you could say like this application uses this warehouse, or you could have multiple. You could also have multiple databases. So you could say, okay, here's my stage database. Here's my my production data warehouse, and here's my application database. And then between those, maybe say, okay, 3 of these tables are just clones, because I want this one to always have the master one that we're going to update, and then these other tables just query, these other ones query off of that.
Say SQL Server or RDS or something behind the scenes.
Yeah, so the things to consider, right, is if you're on something like RDS, like latency. So Snowflake, like my rule of thumb is that you're going to pay a quarter to a half second of network latency. So where we actually outperformed Teradata was because we tuned everything else, and we essentially took a 2-second latency hit and then still outperformed the other pieces. So those are just the things to consider. Like if you're looking for millisecond responses, you're still better off using something like Redis. But for like analytical applications where you have to, like a user is asking a question and you have to go and do these massive compute patterns, this is a really relevant use case for that.
So could I put Redis in front of Snowflake?
I mean, you could put a driver on there that says, hey, like when I make these changes, load Redis, and then have Redis be the point that it hits. So it's just that just comes into your caching strategy around it. And then in that case, then you might, let's say this does all of your nightly stuff, and then you just populate Redis during the day for your application to run. Then you come and you crunch it again, you drop everything from Redis, and then you reload it at night. Like that could be a valid use case.
This is cool, but it's not a hammer, so don't use it like a hammer for everything now, right?
No, so that was one of the things, like do's and don'ts of POCs. Don't try to ram in a use case that pushes an application to its absolute limit. So in Charter's case, they were trying to hit a sub 10-second response time because Teradata couldn't get down below 20. And we actually tuned it down to 8 on this, but it was yeah. And I mean, that's like making it a well-oiled machine out of the gate. One of the things that Snowflake loves to preach is that it's more of a tool for everyone. So it does a lot of the learning for you. And in that case, you just you can't. It's never going to learn its way down to that type of thing. That's where we get paid money, though, right?
A little bit. I mean, but you're building a rigid solution. All right, I'll go through it. Thank you.
All right. So then the other pieces here from a demo perspective that was really just focusing on for the larger group was, let's say I want to start looking at some of these larger data sets. So you can see here, I'm going to pull, Snowflake has some sample, essentially, dimensional warehouses, and these range anywhere from a couple gigabytes to multiple terabytes of data that we can just query as partners. So in this case, what I'm looking at call center IDs, and so this is a call center table that has, I think this is just one of the dimension tables on it. You can see I have all these different pieces, but I can come in and I can start doing some different queries across some of these ones. So I'm going to come down to this, I'm on the TPC SF10. I can come and look at this and I can say, okay, what are all these tables? Let's see here. Catalog sales is a big one. Oops. It's a lot easier to type when I'm looking at my screen. So I'm just going to run a count on this table to see the total number of records. And this is going to query some of the different metadata components of that. I can see here that I've got about 14 billion records in here. But I can go through and I can start doing different queries against this to say, okay, how much do I actually need from here? So I could say, hey, give me the top 10 records. Actually, it's been working on Teradata a little too much. I'm just going to get 10. So this is where it starts to get more interesting when we think about, how do I start to design some of these different queries and then say, pull in the data that I need. So limit commands, tend to be more expensive. And that's because it's just saying, well, find 10 records. I could do things where it's a specific row number or something else that triangulates faster. But I can start going through and say, okay, how do I want to look at this stuff together? So you can see here I have a ton of different keys. So maybe I want this CS sold date SK. So I'm going to do that. I'm going to resize my warehouse just because I know this data is a lot bigger. So I'm essentially going to sum it up by this. I'm going to run it. Now it's essentially kicking off the job. Oh. Now it likes my query. So this is where now you can see it's crunching. It came back with this number of records. We can see how many gigabytes it actually scanned. And then I can see this different information. So there are things that we can start to do across large data sets. Let me see if let me remember which one it is. I'll have to find it, but there are, I'll send that to you guys afterward. There are things like hyperlogs. So, when I start talking about like tens of billions of records of data, for things like counts, the question is how accurate do I have to be? So I can either count it, and it can be a really expensive transaction, or I can use things like hyperlog logs, which are essentially saying approximate me values across all these tables.
HLL, store accumulate, HLL, store combine, estimate, export.
Let's try that. Too many things, oh. I should probably take a SQL class. Invalid argument? It's because it doesn't like that it's a number. You can trust me that the other demo was easier. Nah, it still hates me. I'll find a valid query plan sometime. But I can essentially go through and I can start doing these sorts of queries at scale with us. So when I spun up to an extra large, I was able to pull in a lot more data quickly. So in this case, it actually tells me how many gigabytes I scanned. If I was to look at this table, did I just lose it? There we go. If I want to look at, I think I might have access to view the clustering for it. So you can see here, like when I'm looking at my clustering ratio, so I can start doing things like saying, okay, like my clustering ratio here is 30, so being lower is typically better. Think of it as like skew. So skew being how many things do I have on one thing. This is where it starts to get into like how do I tune my tables to be performant. I could also say, okay, show me the clustering information on that. And here I can actually look at, and so now I can see what's clustering by the keys of sold date and item surrogate key. And then it shows me the number of partitions that I have on that. So typically, when we're looking at this, we're saying, okay, how many overlapping partitions are there? Overlap isn't necessarily good. That means that I've had to replicate a lot of data in multiple places. From a key perspective, how is my data actually being queried on that? And then, what's the depth? So how many levels down are each of my partitions going? Yeah.
Are those things that you can tune, or is it just providing what the agent has decided?
So it will either auto-tune or I can actually set it to that. So this is where, from a tuning, like we could say, well, hey, like people always query by date. Like I should probably partition it by date, or and then by in the case of char, like DMA. So we always order from lowest to highest. So like the fewest number of things is typically, like in char's case, would be like DMA, because there's only 89 DMAs, whereas dates there are thousands. So the ordering is important too. So that way it says, okay, here's how to separate that data out. But then it says, okay, when it goes and executes, based on the metadata for each of those partitions, the query plan will actually say, well, here's how much data I need to scan. So when it's a poorly written query or poorly clustered table, you're going to scan hundreds of gigabytes every time, which is really expensive just from a warehouse perspective. So to make it more performant, that's where we manage the partitions and say, great, I only have to scan 10 gigabytes of data to get my result. The other piece, so in the demo, someone asked, like, I think they were coming from like Oracle and some of the other things. How do I just view different information about my tables? I can see here there's a lot of different things I can do in the information schema. So I don't find this to be particularly interesting, but you can see different attributes. So I could set like time travel options on different tables. What are the different things like when was the schema created, when was it deleted, different comments on the table, fail-safe things, all that fun stuff.
Does it have any kind of optimization tools built into it, like where you go, hey, just run optimization, tell me where I should be focusing?
So I use the visual query plan for that. So typically, if I was to show you a few of the charter ones that we did, like we'd actually look at, because it maps it all out in terms of a giant decision tree, and we'd say, okay, like what's the operation that's taking the most time? And so that was where we came to the conclusion that we actually needed to change, like we needed to go in and put in our own clusters, because we had 1 or 2 transactions that would load the entire table every time. And I mean, it was only a 100 gig table, but when you're talking about 8-second response times, like that's a really expensive thing. So as soon as we tuned that and got it to actually use those partitions in the proper way, that was where we shaved off 3 or 4 minutes from the query. So you do have all that available to you. It's not going to automatically optimize it for you, just because that gets really into, okay, like how do you not fight the current when you're working with the tool and all that stuff. All right, what other questions do you guys have? That's the end of the prepared material. Yes?
You wanted to play around with this? Is there an account, or can we get access to some sort of demo area?
Absolutely not. Yeah, so if you guys are interested, I'm happy to. So we as partners of Snowflake get roughly 800 or 1,000 credits a month. So credits for warehouse usage. Happy to set you up with a key. Just don't abuse it. We can tell who the abusers are right now if we're really curious.
Jason. I would assume you'd be the.
I don't do a ton of stuff in here right now, but I could come and I could look and say, okay, what's my billing and usage? Chicago IM&A really needs to get their act together. Here are the different pieces on that. Here's my by day. Let's say I want to go to June. I bet you I was probably the worst in June. Oh, I wasn't. Here are all the other pieces that ran. So I could say, I have a lot of stuff in this one. So here's all the little warehouses that we created for the client demo. Michael Warehouse XL is taking 51 credits. So it's an extra large. So 51 credits, he just costs us $200. Like, what the hell is he doing? That type of stuff. So from our client, like if you think about from a finance and accounting perspective, Nike actually uses something like this to bill back departments. So they say, hey, you know, this warehouse, like your database is this size and you use this many credits. Here you go, finance, here's an allocation back for 10 grand this month, or here's an allocation for 5 grand. It's also available in AWS Marketplace, so if folks have different accounts, they can come and spin up standard clusters essentially whenever they want. And then of course, you know, what's a good one without a resource monitor? So I can see here, you know, New York has set a credit limit for themselves on theirs, but they haven't used any credits. So there's some decent monitoring that's just built in.
How will this deal with joins? Table joins?
It's
No different than any other database?
Yeah, I mean, it really depends on like what are you joining and how are you doing it. So Snowflake, if you think about like just general like good design principles in Snowflake, and I'm going to compare it against Teradata because that's what I've most recently done a comparison on. Teradata loves small things where you take a big table, you reduce it really quickly, and then you join it together. And for Snowflake, that actually really messes with their query optimizer, and you don't enable it to say, okay, like based on all that and the n number of partitions available to join, you know, what do I do with that? So in Snowflake, you're better off building larger queries in most cases and letting the optimizer figure out what to do. And then you can go back and say, okay, based on what the optimizer came up with, is that a good or a bad thing? So short answer, it depends. Long answer, typically the more, you know, build it into a query and then see how it works. I do a lot of things like just common table expressions to make sure that it's legible, and then if I need to break it apart into temporary tables, it makes it really quick to do that. But that's where it comes back to like, what's the cost of that network transaction versus the cost of the query? Other questions?
Where are you seeing this most appropriately used compared to maybe other solutions?
Yes. So data warehouse migrations, most commonly the things that we hear about now are Redshift migrations, Netezza migrations, Teradata migrations, on-premise migrations. I have not seen so we do have one client where they're going over their usage, but that's because they don't understand why something is pinging one of their warehouses repeatedly. So most of the time, I'm a pretty big believer that it does end up being a value proposition for our clients. Where it's not, you know, if you can't get a client past the conversation of why to go to the cloud though, like it's still gonna be a non-starter. So they do have an option called virtual private Snowflake, but it's essentially still in your AWS VPC. It's something that they worked with Capital One to build out. So it gives you even more data privacy, you know, from that perspective, but it's still in the cloud. So if you have a client that's like absolutely not going to the cloud, tough for us to have that conversation.
But you're focusing on data warehouse applications, not transactional usage, et cetera.
It depends. Like I see this as in a lot of cases our clients are looking at this as like a data lake replacement because people don't know how to query S3. So I can just load in all my JSON data as variants and then users can go query it or applications can go query it, and it's usually pretty performant. Transactional use cases, it really does, it's a case-by-case basis. So in the example of our clients at Charter, it's a perfect fit, but that's because they query their data warehouse to give their users data. In cases where it's like, you know, your banking app that you're using on your phone, this is probably a really poor fit because the latency alone will drive SLA issues.
Yeah, so we had an issue, we were doing something in Pearson, and Jason came in to help them with some, I think it was Redshift or...
Oh, it was like EMR.
Yeah, EMR, so to do basically. And they couldn't get the answers in a timely manner for a couple of reasons. One, they were spending a lot of machinations massaging their data before they put it into Hadoop, before they ran the queries in Hadoop. But then they were setting up their Hadoop cluster wrong. So instead of, if
Yeah.
giant files. Whereas if they're using this, like you obfuscate that, right? Then you don't care about like the underlying infrastructure. You just basically run a standard select query, and because you can do like the limit or some of these estimates, they could have gotten and like a lot of times when you're just trying to understand like what's out there, you just want to get some answers quickly, just to shape where you're going to go explore. They couldn't even get to that because the data was just so unwieldy just to start, and they couldn't even just like consume just a couple chunks of the data just to try out because it wasn't meaningful. But this we could do very quickly. So I see it as a really great data exploration tool, answering questions quickly.
Yeah, so it's good at that. Like you can unload anything from it, so I can actually like do all my work in the like treat this as an EMR replacement, so I can do all my work in it and then unload the finished product to S3. That in that case, like they probably should have been using something like this because they're just looking to repartition all the data and then pump it back out. It doesn't excuse you from a client having the conversation of, is this the right tool? So in some cases, our clients will bring the 25-pound hammer when a 16-ounce hammer will do. But that's because they don't understand, what's available with A versus B. So in the example Sean gave, like what they were doing was something that we're doing at Charter with a single medium Linux instance. And for them, they're doing it on a 16-node EMR thing that I think literally one of the guys said it'll only cost us 15 grand to run over the weekend. That's acceptable. And I was like, all right, man, like not my money, but that's the problem, right?
I have a question around a little bit less technical, obviously. What are some specific capabilities that makes us unique to position Snowflake for a client, or if we're talking to a partner, what makes us unique than any of their other partners? So if I'm having conversations with the partner, why does Snowflake want to use and bring opportunities to us, and why would a client want to work with us?
So usually it's a couple things. So one is that we're actually cloud agnostic. I mean, it's cloud agnostic that you can pick 2 or 3. But from a technology perspective, I think we understand how to port stuff over to this because it's not just lift and shift in most cases. Like they love to sell it, how do we get it in there in a couple of weeks? But that's not in reality that never happens. We're talking right now about a conversion. It's okay. Well, it's 6 to 9 months. It's 6 if we can lift and shift. It's 9 depending on how much we have to re-architect. And it's being able to just say, okay, like what's the thought leadership around that, and then how do we make that reality? We have a lot of work with the platform. So even though a lot of the stuff, it's like I liken it to skiing, snowboarding. It's really easy to get out of the gate on Snowflake for our clients, but then when you start thinking about the cost patterns, like how do you scale it so you have 10 departments that are using the same data sets? I factor in sharing. I think we bring the right strategic mix to that conversation to figure out, should you be sharing it? How do you share it? How do you lock it down? How do we apply governance around that? We're not just a data warehouse shop, right? There are some of those around, and they can pump out that stuff all the time. But then you think about all the supporting things that are needed, because at the end of the day, this is just a piece of technology. Like they don't have that.
I've seen a lot of times where our clients actually never heard of it. So being able to bring them an option or a technology they've not heard of, because they've had their AWS rep, Redshift, or what's Redshift? What's the other Redshift?
Redshift Spectrum.
Redshift Spectrum. It's the bee's knees, or the Google person's telling them BigQuery is the future, and it's pretty cool, right? But being able to bring them an additional option that looks a little different, because Redshift sounds great until you actually start trying to set one up, and then managing it and keeping it alive is not fun. Whereas this, it's a different kind of not fun, because it's less low level not fun. It's more thinking about how your users are going to use it. So
I tend to shy away from just saying like, if it's, if 1A is yes, then 2B is no, then we get to 3, which is this thing, and that's because a couple of things. So one, I rarely go in and recommend a cloud anymore because a client's on a cloud. Like, take Western Union, they're on AWS. Now, do they want to move to something else? That's probably like a CIO level conversation. Second piece is, when we try to figure out, okay, like what are the right technology pieces, if we start talking about technology out of the gate, typically what that precludes then is us saying, well, like, is that actually the right thing for you to be doing for that outcome that you're trying to define? So like Snowflake is great, but if in the example Sean was using earlier, if it's really that you're just trying to get data into a way for your data scientists to leverage that, like this might not actually be the right solution out of the gate. Like we have to go through and say, okay, what are the things in the opportunity that would say, here's the piece that we have to bring in?
My question or comment might have been misunderstood too.
I'll get you where I'd say yes.
I'm not trying to imply that you give us some magic formula so we don't need to come to you and come to you. We're just saying, hey, if then, right? I think what I'm trying to ask is there a way for us to do something as simple as when a client's in a situation where some set of conditions exist, they're not afraid of the cloud, they're maybe a multi-cloud environment, and they've got problems with mastering or with warehousing or whatever it is, this might be a good solution, and that kind of solution is not appropriate. And or if we're ever on these phone calls that we end up having with Google, with AWS, in partnership calls, they get kind of mad at us when they're sitting there trying to sell to these same people, and we're not supporting it. I feel like we ought to be able to say, look, I understand you guys want to sell it here, but this is a better solution for that kind of situation. And if we just have some level of communal understanding.
To give you an example, what I think would be useful is like the example down in Charlotte that Jason referred to a few times. We have a solution. It is, the best performance we can get is 20-second queries, but we have a customer literally waiting on the phone for the answer for what we're trying to figure out. We need to deliver those answers faster. And we don't have a good big operations team and that sort of thing. Well, Snowflake may be an option for that, depending on what you're trying to do. But you realize you may be making rigid, it's not to say, what I'm trying to do is get you to these are the stories, right, that help you understand when something may be an option. It's not a flow chart, it's not a decision tree, right? You cheat go down like Snowflake is the one true answer. This is an option, but like Jason's saying, they've already got some technology. What we want to do is, so we're not coming in with like the nerd walks in and just has a bunch of technology things. It's more like, what are you trying to achieve? And it could be maybe they are not even thinking about what they're trying to achieve correctly, right? So you got a customer on the phone, you're trying to answer a question. It's interesting, and you got this tooling set up. Okay, so why is your customer having to call you in the first place for this? Why is it not showing up for, right? Could be those sorts of answers.
To me, like if you've gotten to that level of detail, like you've qualified the opportunity, and then it's okay, how do you bring in like a Sean or myself to then say, okay, like what does it actually look like to like design the outcome?
I think there's some value though.
Like if you
bring the thought leadership to them without, and being able to have a conversation. Hey, I don't know a whole lot about this, but we were just talking about this. There's, what you're describing sounds like a situation where you talk about Snowflake. Do you know anything about it? And 9 times out of 10, the client goes, what now? Like a Snowflake star schema kind of design thing? No, this is something else. It's a tool. Oh, well, let me see if I can get Jason in the room, right? I think that's kind of what you're getting at. It's not to like get down and really design with them.
That's right. I mean, it's not really about the technology. But if we do have a position, what is it?
Yeah, we've purposefully avoided the bake-off situation, because we've had clients ask us, hey, do a bake-off between Azure and AWS, for instance. And we've purposefully avoided that type of work because it's a zero-sum game. We lose, everybody loses. We lose as a partner, we lose to our clients, we lose to our partners, we lose to ourselves, because the reality is, if you ask all of the cloud practitioners here that have experience with multiple clouds, they will tell you there's some things that are good, some things that are bad about every one of them, and we can work around it. What we tend to get more frustrated with is when people try and use it's like my wife uses, when she's using the screwdriver as the chisel, right? And she's like, why is the screwdriver bent? Because she uses a chisel, right? I did it last time, I don't know, we're taking it, right? So I shouldn't blame my wife for these things sometimes, because I'm guilty too. It's nice and handy, right? Almost all my screwdrivers are back ends. I beat on them, so. I think it's good to have the stories, and I think it's good to have I don't want to do the strong opinions loosely held, because that actually means you don't have any information. What I tend to say is we have strong opinions around philosophies, and loose opinions about tools, if that makes sense. Because the tools are just a mechanism. What you're doing with the tools is actually what we care for. Does that make sense?
Most of the time it does, but it felt like during the last hour and whatever, that this tool brings certain things to the conversation that maybe other tools don't.
That's correct.
And I don't know what that is. I mean, I understood most of it. It's just half of what you were talking about, but I can't compare that to anything else. And I just wonder, in order to bring you guys in, I think your point, right? So let's assume that we're going to a client who says, AWS has been selling us on this, and we're thinking about going that direction. And at what point would I have any confidence in saying, have you thought about Snowflake, and can I bring one of these guys in? Well, why would you tell me about Snowflake? I don't know.
So
this I would say, I mean, this like.
Sorry about being
No, it's fair, but I think this is where you get to like the case by case things, right? Because one is, okay, well, how did we get in? Was it that AWS referred us to the lead, in which case, we really have to be mindful about, the right pieces to pick, regardless of solution.
But also, assume we're already.
I know you're not.
Right? So assume we're in the client, and they didn't bring us in. It's just.
I'll give you an example of how, I'm hearing your ask, and I have a vision of what it is. I need something from you, because let's say that I was going to compare BigQuery, Redshift Spectrum, and Snowflake. It's a pretty common thing, but maybe even Azure Data Lake, right? Those 5 things. And I want to do like a pros and cons, or a back to the box, feature thing. That is not useful. It is not useful to me, because it doesn't matter, because you can make them do all similar things. What I think would be more useful for what Doug's thinking about is, let's say you got your 5 products across the top, and you've got like some Harvey balls down there, or ratings, or notes even. Is what are the criteria that you think that in general customers would care about, especially at the level of conversations that you'd be having, like a CIO or a director or something like that? Because it would be things like, how hard is this to administer? What's the learning curve? Who is the standard? Who would be who are the users that you want to support with this, right? Because if this is, maybe this isn't great for data scientists, but maybe Redshift is. I don't know, right? That way you're answering the real questions, not the like, this thing is better technology or something like that, right? Because that's the wrong conversation.
No, it's more usage, I think, that you're talking about, right? So you said the data science type of application, right? Another one might be, what if it was really high transaction volume? Would you care about those?
The streaming thing, right? So it's like the Western Union case where they want to stream in all of their transactions and be able to query those things in real time and make sure that the new ones are always fresh.
Good to talk to you.
Some of this variability that you were talking about, what if somebody was extremely either seasonal, or they just had really high volumes and really low volumes? Maybe that's a reason why you say, maybe I ought to take a look at something like this, because you're buying all of this and only using this 10% of the time.
That's a great thought, because Richard, you're paying all the time.
Yeah, I think to me, like, from my perspective, if we're having, it depends on the level of conversation, right? If I'm talking to the director of technical architecture, I'm probably bringing a point of view on, why we like a technology more than the others. Like I typically say, and Like this is my talking points if I'm talking to someone about, okay, how do I credentialize myself? I say I like Snowflake, Data Robot, and Databricks in terms of up and coming things in data. If I'm talking to a CIO, it's rare that I bring up any name like that because my thing is, okay, you're probably concerned about your IT spend, how many people you have to support that, and then what are your key objectives, whether that's getting out from under the CFO or doing something else. So if I'm nailing those 3 points, like I avoid the technology as a part of that and just saying like we're going to deliver you an outcome that hits those 3 things. Because at that level, like I'm probably not concerned about whether it's a specific thing. I just want to know in the case of like, what are you recommending to me that's not going to go away in a year and get acquired and then get EOL'd? And then how do I bring something to the table that they're excited about? To me, it's just like, what is the conversation I'm trying to have? And then that's what I'm tailoring it to.
I understand your ask. There's a couple things to dovetail in, so I'll see if we can. I can't guarantee anything.
Good to see you.
I'm talking about is, account team, BDEs, alliances, and I think we're talking about this is way before a conversation, and we're not trying to replace a conversation, but we would bring you guys into in meeting 2. It's about helping us figure out how to discover an opportunity, right? Open up a conversation. It's not we're not trying to solution this thing. I don't even want to go there, right? But
What's our partnership like? Is it relatively new? Are we tight in area to share?
So actually, that was going to be kind of my piggyback question is, what stories do we have? I know that kind of from a partnership perspective, we can focus on them, but where have we delivered? What are our capabilities around it? And actually, I'll kind of piggyback a little bit on his question is, what's our point of view, but also when I'm talking to these partners, AWS, Google, Snowflake, whoever it is, I'd love to have kind of like my own tool chest. Here's what our capabilities are, and here's what we do really good. Right?
Here's what we do and don't do, and here's what we really want to do.
Yeah, because I want to be able to tell those stories, and I want to be able to say, that's why you want to work with Denver, or small environment, this is kind of like the work we want to do. Because I get asked these questions, and sure, we'll do a migration or a lift and shift, or I know we won't,
That's the
but
problem is like
yeah.
migrations come up like for example, migrations come up all the time, and if we don't take that line in the sand of like we don't do migrations, or we do migrations, but they must be this way, right?
Like we'll do data warehouse migrations, but you guys won't do just infrastructure migrations.
We will, but we're very opinionated on it, and we will not do like just bullshit.
Lift and shift.
We'll do lift and shift, but we won't do bullshit lift and shift, and we're not
Yeah.
lifting and shifting.
They're very opinionated.
Yes.
It has to be like the 1 out of 100 engagement for us to do a lift and shift. We have more work that's more satisfying, that pays better. I mean, lift and shift is a commodity. If people are just literally trying to move as fast and cheaply as they can.
Yeah, I mean, I think, so like, my perspective is that, if you're having a conversation about capability, the thing is, okay, like we do data warehousing well, we do data analysis well, we do, machine learning and data science, and then we do like the data engineering. IM&A has a very different problem than TE in that TE, you can like pick 3 things. You can pick Google, you can pick AWS, you can pick Azure. And then there's obviously other things like when you start to talk about automation and things where I think, you have to, there are just so many tools and it does change. But for us, there's 100 partners that are listed on the Alliance page, right? Like there's no way any of us are gonna know every single one of them. So the more that we can not have a conversation about our capabilities in a specific technology, I think the better off we are. That said, our partners always ask us for that, right? Like, well, how many people have AWS certifications? How many people are certified in Google? Like we can check those boxes and then it comes back to, okay, like here's the things that we've done. And we should always poach national stories when we can. So like Google is a great example, 0 local credibility. I'm being recorded for this, we should delete that part out. So like, we have Total Wine, we have Home Depot, we have Coca-Cola, we have things where at the end of the day we can speak to what Slalom has delivered on these different things, and those are still outcome-based stories that we're focusing on. From an alliances perspective, right, Snowflake on Azure or AWS, it's like they kind of win either way. When you talk Google, like that's a little bit more difficult, but I know that that's all, like those conversations happen, and so the question is like, we can outline pros and cons of each of them, but I don't know that we necessarily come with like a point of view other than like, yeah, we like working with this. Snowflake, there are more wins on the East Coast. Like we've done it at Charter a couple times now.
Was it there first, or did we bring it in?
We brought it in.
Are you finding that to be the case more often, or are you coming across this and being, hey, we've got
If people don't have like it depends on whether a client has a predefined view, right? If a client's like, well, like, I don't know, like, well, typically, like, we would probably use Snowflake just because we can get up and running the fastest and we can get to value faster. So the question isn't so much like, is it the best thing ever? It's that we can get to value faster than we could have with something else.
That's kind of why I wonder, like, if people have bought it for that reason, so it's very approachable, you can get your team doing something, but all of a sudden you realize, like, you start to learn what you need to learn kind of thing.
Yep.